Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 4, Section 6, Matrix Transformations. So starting with a few terms. The word transformation simply means change. In this context, we're going to be taking shapes and changing them. Perhaps the change could be a sliding up and down, or left and right, or both. Flipping, like a mirror image, flipping it over the X or the Y. The change could be a rotation. In this section, we're going to limit ourselves to just a rotation counterclockwise around the origin. Remember, the origin is the ordered pair 0, 0, so that's going to be our rotation point. Or we will do a dilation, which is making a shape larger or shrinking it by a certain factor. When we notate these shapes, the pre-image is defined to be the shape before we make any changes to it. For instance, an example of this, we could be talking about triangle ABC, and we will be using capital letters for their vertices. After we do the change, we take the pre-image, we do the transformation, and then we get what's called the image. And when we have the image, we use these capital letters with prime symbols. A prime is the change that we made to vertex A to its new location, B prime, and C prime. Okay, Roman numeral 1, the first translation we're going to talk about is the slide. This is in bold print here. This is like the formula. Take the matrix that is the initial, the pre-image, the XY, and then we'll add to that the translation matrix, which we have to create, and that will give us our image matrix. So looking at an example of this, we are asked to translate the triangle 3 units to the left and 2 units up. So from our previous knowledge of the XY axis, we know that 3 units to the left, we know that the X is the left-right coordinate, and if we go 3 units to the left, we are going 3 units in the negative direction on the x-axis. And so this is referring to the x. 2 units up, we know that the y is referring to the up-down part of the grid, and 2 units up is a +2 movement. So that's going to help us build our transformation matrix. So let's first make the matrix of the triangle ABC. Now I have come to have the habit of putting a little header here labeling my matrix so I know which coordinates go to which vertex. So the coordinates from vertex A are 1, 1, from B 2, 6, and C is 4, 4. And now we need to add to this the matrix we're going to make that's going to do these changes. So if we want all the x's to go 3 units to the left, we're going to put a -3 on the x, the top row, which is the x location, and the y's we want to go 2 units up, so we're going to put a +2 for all the y's. And then we simply go ahead and add these. And again, I still just label it. It helps me keep everything straight. So adding these, check my addition, gives us A prime, B prime, C prime. Now I'm going to attempt to graph this, which is kind of a challenge for me without grid lines. So A, -2, 3 is approximately here. B is -1, let's see if that's 6, 8 would put it right about here. And C is 1, 6, put it about here. So then if I can connect these vertices and label them, this would be A prime, B prime, C prime. All right, Roman numeral 2. The next transformation we're going to look at are reflections. And I think of a reflection as like a mirror image. notice again, we're going to find it by using left multiply. So we're going to left multiply our pre-image matrix by whichever one of these reflections we're asked to do. If we're asked to flip across the y, we use this matrix. Flip across the x. We may flip across the line y equals x. So just to remind you what that looks like, this line right here is the line y equals x. We might be flipping over that. Or we could be going over the line y equals negative x, which would be this line. So we'll have to select the correct matrix for whichever transformation we're asked to do. So in our example, they say reflect DEF. We have two things. First, we're going to do part A. We're going to reflect it, flip it over the y-axis, and then we're going to flip it over the line y equals x. So let's select the correct matrix here to flip it across the y-axis. And I see that that is the -1, 0, 0, 1. So I'm going to put that down first because I have to left multiply. So now let's write the matrix of the triangle. Okay, that's not showing up real great, but I'll let you know what it is. So we want DEF. So the coordinates for D are 2, 1. In case you can't read that, it's sort of hidden behind the triangle. I should have fixed that. E is 5, 3. And F is 5, 1. So now we do our matrix multiplication in order to get D prime, E prime, F prime. And I think with these easy matrices, you would be quicker to just multiply it by hand instead of entering it all in your calculator. So let's try to graph this now. I'll give it a good try on without grid lines here. So -2, 1. Here's my D prime. E prime, -5. Close here. -3 is right about there for E prime. And F prime is -5, 1, right about there. So I'll attempt to connect these vertices. So there is our triangle reflected over the y-axis. The y-axis is kind of, I think of it like a folding line. If we folded it, these should match up. So now to do part B transformation, I chose the correct matrix to flip it over the line y equals x, and then we're going to left multiply by the same matrix from the vertices of the triangle. So again, doing this by just your brain, I think, is better. So if I multiplied that correctly, then I just labeled this D double prime, E double prime, F double prime. And in essence, when you flip a shape over the line y equals x, notice that the x and y coordinates are just trading places, and that's what happens when you do this transformation. So let's graph D double prime. So we have here 1, 2. It's right about here. So we'll mark that, and then 3, 5 is about here for E double prime. And then 1, 5 is about there for the F double prime. So attempting to connect these vertices. All right, there's the image now after that transformation. All right, Roman numeral 3. Now we're going to do rotations. Remember, we are limiting ourselves to rotations that are counterclockwise going around the origin. Once again, it's a left multiply. To multiply your shape 90 degrees counterclockwise, this is the matrix you use for the 180, this matrix. To rotate it 270, this one. And notice something interesting about the 360 matrix. If you look carefully, this is the identity matrix. But if you think about it, that makes sense, because if you rotate a shape 360 degrees around the origin, you're right back to where you started, so there is no change at all. In this example, we're asked to rotate 90 degrees around the origin. So I selected the matrix for the 90-degree rotation and wrote down the matrix from the 3 vertices of the triangle. So once again, we do a left multiply of these 2 matrices. So please check and make sure I multiplied that correctly. And now we're going to graph the image. So we have negative 3, 1 is approximately here for the D prime. Negative 1, 4 is about there for the E prime. And the F prime is negative 1, positive 1, right about here. So let's see if I can connect these vertices to sort of look like a triangle. All right, and there we've rotated it around this. This is our rotation point, the origin. So we kind of stood up there as we rotated it around. All right, this last transformation is dilations, meaning that we're either going to be reducing the shape, making it smaller, or making the shape larger. This one's a lot easier. It's just multiplying by a scale factor we'll call k. And this is a little Captain Obvious, but we're going to go through it anyway. If you are reducing or making the shape smaller, your factor is going to be a fraction in between 0 and 1. If your factor is a 1 exactly, you have not changed the shapes. Your transformation will be congruent to the original. And if your factor is bigger than 1, you are going to be enlarging the shape. So pretty much common sense. In example 4, we're asked to take this shape that's got 4 vertices this time and scale it by a factor of 2.5. So obviously we are going to be enlarging this shape. So if your scale factor is 2.5, I can just go ahead and put that right in front of the matrix. And then let's pull the vertices coordinates of these 4. So now I have this set up, and if you recall, when you're multiplying by scale factor, you just multiply the 2.1 times every single element in the matrix. Alright, so I think I multiplied that correctly. So the last thing to do then is to graph this on the same graph as the pre-image and see if we can get an image that does look 2.5 times as large. So I attempted to graph P prime, Q prime, R prime, and S prime, and then connected those vertices to show that we did in fact enlarge this shape by a scale factor of 2.5. Alright, I think you have the knowledge you need to do section 6. This is the last section in the matrix chapter, so have fun with math.